Hello guys, welcome to the YouTube channel. In today's video, we are going to talk about the interview questions from the cumulative distribution function and the probability density function. The statistics is the key pillar in the data science. So any data science or any data analyst interview, the people are trying to ask some basic question from these two concepts. I will give you a touch of the question which can be expected from this topic, and with that, let's start the video. So the first question is, what do you understand by the mass in probability mass function and by density in probability density function? This is not a very famous question but can be expected in the interview. To check your knowledge about the definitions, so you really understand the meaning of the probability mass function or probability density function. Let us suppose you have a rod and you keep some masses in that. Say the masses are m1, m1, m2, m3. You keep in the position of x1, x2, x3. Okay, here the m1, m2, m3. So in this rod is a length of L, and you keep some masses at the different position. So if somebody asks what is the total mass, so total mass, simply what we do, we just add these three mass, m1 plus m2 plus m3, right? So this is the total mass of this rod. With this scenario, we can describe a function that is a pxj. The pxj will be the mj for j is equal to 1, 2, 3, and it will take the value 0 otherwise. Okay, you can define this function. So once you define this function, now with the help of this function, the total mass is px1 plus px2 plus px3, which behave in same way as the probability mass function behave, because the probability mass function short form is PMF is used to calculate the probability for the discrete random variable. Discrete random variable means the random variable which are countable finite or countable infinite. So which is defined as Px of x is equal to probability of x is equal to x. So the meaning of this scenario is same as how we calculate the probability mass function. That's the motive we use the mass in the probability mass function. Now, for example, if you have the Bernoulli distribution, so Bernoulli distribution defined as probability x is equal to x, and it is a p if x equal to 1, if x equal to 0, it is the 1 minus. That in one trial we get the success or failure. So Bernoulli distribution is an example of the discrete distribution, and to calculate the probability in the Bernoulli distribution we use the probability mass function. So basic idea is that we use the mass in probability mass function because its idea to calculate the total mass and to calculate the probability of discrete random variable is same, right? So that we use the mass in probability mass function. Now the second is the probability density function. Why we use the density word in the probability density function? So again, if you suppose this is the rod of length L, and there are the different position we have, and suppose this rod have the varying density. Okay, the density is varying always. Now in the discrete random variable we have one value at a one position, so we just add it and we tell this is the probability. But here in every point that this rod have the infinite number of points, and at the infinite number of the point this density is varying, thus changing. So to calculate the total mass we will use the integration here. So here the total mass is equal to the rod length L and the function fx dx. This fx is same as the density. Okay, so we will do the integration and we can calculate the this density, this total mass. We can calculate this total mass. So now in the continuous random variable we will use the probability density function, because the continuous random variable will take a value between the range of 2 points, and between the range of 2 points there are the infinite number of the points. So to calculate the probability we use the probability density function. Now the probability density function behave as the same way like how we calculate this total mass, except the unit dimension, because this probability have a probability per unit, and this is the kilogram per meter. So like this you can explain in a easy way. I just tell you in a broad way, but you can explain in a according to your way. Now moving to the second question, how do you interpret the cumulative distribution function? The cumulative distribution function actually gives the cumulative probability of an event occurring. Cumulative probability means what? The probability that event occur along with the previous event. So generally we define the cumulative density function as capital Fx, and it will be the probability of x less than is equal to x. So this is the cumulative distribution function, exists for both the case discrete as well as the continuous. Okay, it's always lies between 0 to 1 because anyhow it's giving us the probability. So you should know the basic definition of this distribution. Now I'm talking about the probability, this cumulative distribution function. That means this distribution function have some property, and in the screening test you can get the question about these properties. For an example, if you see this question, in this question is asking which of the following is not a property that the cumulative distribution function of a random variable x must satisfy. So this is the just the asking the properties of a cumulative distribution function. Let me know this answer in the comment section below, and this kind of a question you can expect in your screening test of interview stage. Moving to the third question. Third question is interesting. When do you think to use PDF in place of CDF? So as we know, the CDF and the PDF almost they give the same information, but some kind of analysis, like you want to check the skewness, you want to check the distribution shape, you want to check the peakness of the distribution, that all the things you want to check the multimodality, like we have the bimodals which have the two peaks in a curve. So these all the information CDF can't give you, so these all the information PDF will try to convey us. So there we use PDF in place of CDF. This question is an important. Now moving to the fourth question. The fourth question is again can come in the screening test. Which of the question is which of the followings are not necessary true about the probability density function of a random variable x. Probability density function have some properties. So this question, these four options is talking about that. If you see, the probability density function is never less than equal to 1. Okay, so A option is not true, that is our answer. B, our the integration, this all the total sum should be 1 in the case of the continuous random variable. Third one is the wrong according to the property, and fourth, which will be the greater than equal to 0, because anyhow the probability density function calculating the area in the interval between the 2 points. So the area is negative area not make a sense, so that means it should be greater than equal to 0 for every x. So this kind of a question you can expect in the screening test. I hope this 4 question give you some touch regarding the CDF and the PDF. Please if you like this video, then please like, share and subscribe to my YouTube channel, and in the next video we will again meet you with another question from the different topic. After that, thank you, take care, bye bye, and keep watching.